Yeah, hello, how are you? So today there was a live presentation by Professor Babu Wino on mathematics revision for candidates, and that clearly motivated me to try and do something to support Bwana Mheshimiwa. Now I've decided to just uh, go through one of the past papers to at least share my experience with candidates on how they can look into the papers or how they can answer their mathematics questions. Uh, this is not like the math cannot have one method, so there are so many ways of doing it. So sometimes I might use different methods than the one someone knows. So feel free to apply your own method. And just a little bit about myself, I'm Martin Ochie, and at some point I taught uh, mathematics in high school, Form 3 and Form 4. So I've been to a revision class and an examination class before. So maybe you might get to benefit from here. I'll be using this screen for presentation. Now, like you see from our past, uh, so I'll be using this, and then we'll have a white paper presentation. So I'll share. I'll be working from this one. This is like a whiteboard. So we have shall be moving from here to the whiteboard. So that from time to time we shall be shifting. Now look at question one. This is a very common question, and most of the time it's always you without using a calculator. So this is just uh, you apply BODMAS to solve this question. And when we talk about BODMAS, so let's just go back to our screen. Sorry. So in BODMAS, you start with bracket, then off, then division, then multiplication, then addition, then subtraction. So those are some of the things you will be able to use for solving that question. Uh-huh. So we shall give it a look. So the question is 1 and 1 over 5 minus 1 and 1 over 3. So we have 1 and 1 over 5 minus 1 and 1 over 3. All this over 1 over 8 minus 1 over 2 squared. 1 over 8 minus 1 over 2 squared minus 7 over 15 of 2. So this is a very common question in mathematics, especially paper one, and I hope things have not changed that much, because the last time I was in a class teaching was 2013. So here we will start with this operation here, which in its sense has a numerator and a denominator. So on our numerator, for me, I like working from side. So you do the simple operations on the side, and then bring the solutions to the main operation. So I'll take 1 and 1 over 5 minus. So 1 and 1 over 5, that is 6 over 5 minus 1 and 1 over 3, that is 3 into fraction. So in proper fraction, 3 over 4. So this one, if you use LCM, our LCM of 5 and 3 is 15. So 5 is 3, that would be 3 times 6 is 18 minus 3 is 5, 5 times 4 is 20. So we get our value as that would be what? Minus 2 over 15. So you have that numerator. So you have one of the solutions is minus 2 over 15. Then you have minus 2 over 15. Then you come and solve the other one as well. So let's Let's start this part. So the next one is 1/8. So minus 1/2. So negative squared will be positive. So that's 1/4. Positive 1/4. But the negative outside remains. So this negative remains. So here you can give us LCM is 8. 8 into 8 is 1. 4 into 8 is 2. So this gives us a value of negative 1/8. So this one will be so when we negative 1/8. So we have, let's proceed. So we have negative 2/15 over negative 1/8 minus, so what's our value? 7/15 of 2. 7/15 of 2. So here we then solve this. We want to simplify this area so that we remove that fraction. So we'll solve it here. So we'll have negative 2/15 divided by 1/8. It will be times negative 8/1. So here you will have negative times negative is positive. So 2 times 8 is 16/15. So this will be 16/15 minus, sorry for mixing the colors, but it's okay, 7/15 of 2. We are still applying BODMAS. So the next thing we will solve here is the off. So the off, we have 7/15 times 2, that is off, which gives us 14/15. So you now replace your solution will be 16/15 minus 14/15. This one gives us 2/15, and you have your answer. So, however the examiners do, I'm not sure. I can't really, know how they award the marks, but at least you'll have all the marks. That question should be how many marks? So this is a question that someone should not fail at all. So have your solution well organized, and just go step by step and solve them until you get your final correct answer. Your final correct answer. So it's 4 marks. That's a lot of marks. Then we have the cube root of 0. Wow, let's see. Okay. So we want to go to the next question, which is also a very common question. So you have your, sorry, let me just wrap that. Let's make our board black. Okay. So so you have okay, sorry. You have the cube root of 0.512 over 0.216. So the question here is very clear, and you can see it is asking you do what? Find the reciprocal of this, and then evaluate this. So the first thing we do here is to find the reciprocal of 0.216. And how do you go about that? So you have, sorry, I don't know what just happened there. Okay. Yeah, so we have, so we start with a, sorry, let me just do it here. Reciprocal of 0.216. This one, of course, the reciprocal of 0.216 is 1 over 0.216. And in your high school mathematics table, the four-figure mathematical table, you have the table of reciprocals. So I want us to write this in such a way that we will be able to use the table of reciprocals. So I can decide to write this in standard form, which is 1 over 2.16 times 10 to the power negative 1. So the reciprocal of this one, still someone could go further and write it as 1 over 2.16 times 1 over 10 to the power negative 1. So the reciprocal of 1.26, we can just look it up on our table. So you have your table here, and this is where you check here. So so you check this one 2.1, then 6. Where the reciprocals. So you check 2.16, so it will be 0.4630. So you have your reciprocal there, 0.4630. I hope you've seen it clearly. This is 2.16, so it's 0.4630. That is your reciprocal. So you have it as sorry. Back to the board. So we have we've seen that is 0.4630. Then the reciprocal of 1 over 10 to the power negative 1 is just 10 to the power 1. So when you work out this one, it gives you 4.630 to 3 decimal places. So you have your reciprocal. That is your reciprocal. You've solved the first part of this question. Then they want you now to solve this. This equation. This problem after solving the reciprocal. And the reason why they tell you to do that is because they want you to use reciprocal to solve this question. So in doing this question again, let me just rewrite it here. Sorry, with black. So we have the cube root of 0.512, and then we have 0.216. So I will decide to solve numerator and denominator separately. So our numerator can be written as, of course, the cube root. We can write it in a way that we express it as a whole number. So we can have it written as 512 times 10 to the power negative 3. So when you move this decimal point to the end, you're going on the right side of the decimal point, so it's times negative 3 over 0.216. Okay, so we can solve our numerator. You can solve your numerator by using factorization. You don't need to use tables here because 512 is factorizable. So 512, 2 here is 256. 2 here is 128. 2 here is 64. So let's have 64 here. 2 here is 32. 2 here is 16. 2 here is 8. 2 here is 4. 2 here is 2. So how many are they? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 512 is just the same as 2 to the power. 2 to the power 9. Okay. So we can now write, the cube root of, sorry, that's it. So we can now write the cube root of 0.512, which we have said can be written as the cube root of 512 times 10 to the power negative 3. And these are now 5 can be written as the cube root of 2 to the power 9 times 10 to the power negative 3. Of course, we know cube root is just multiplying the power to a third. Cube root, of course, can be just multiplying the powers per third. So this is 2 to the power 9 times 10 to the power negative 3. Instead of cube root, this can be written to power a third. And therefore, this can be written as 2 to the power 9 times a third times 10 to the power negative 3 times a third. Okay? So, of course, going down to that will be 2, 9 times a third, that is to the power 3 times 10 to the power negative 1. So 2 to the power 3 is 8 times 10 to the power negative 1, that is 0.8. So remember our original question. Our original question was, sorry for that. Let's use blue. So our original question was the cube root of 0.512 over the 0.216. So the cube root of this we have gotten as 0.8 or 8 over 10. And the reciprocal, remember the reciprocal, we have it here. So you have your reciprocal as, what is the reciprocal? 4.630. So, sorry, let me just write it here. So the reciprocal will be 4.630. 4.630 to 3 decimal places. Of course, this is something that you can solve because this is 463 times 8. That is what? 24. 8 times 6, sorry, I don't really do this simple mathematics. 8 times 6 should be 52. Okay, no. 8 times 7 is 42. So, that is 8 times 6 is 48. Sorry for that. Okay. Simple mathematics. Sorry guys, sorry fellas. So this is 24, this is 48, 50. This is 32. 32 plus 5 is 37. But remember, we have how many decimal places? 1, 2, 3. 3. So your answer is 3.704. And of course, we can verify that using our calculator. That's the good thing about mathematics. You can verify everything using the calculator. So I can do, let me just verify it so that we confirm we are correct. At 0.8 divided by 0.216. Yeah, 3.7 something. Yeah, we saw our answer is correct and you have your mark. So this is something that should be clear to you. Also, let me just recap that question. We had our cube root of 0.512, which by factorization over 0.216. So we were able to separate this question into cube root of 0.512 then times 1 over 0.216. Okay. And so clearly this one you are able to see it was 0.8, and this one you are able to see it was 4.630 into 3 decimal places. And then you are able to multiply this and you get the final answer, which was 3.704. So why have I repeated writing this? Because we've done so many things which when you're doing your math paper, they should be somewhere on the side, like not outside the paper, but just in the place where that question is. You can just draw a simple line and do your rough calculation, which should be organized as well, so that you only have the important part in the work. So you first look for reciprocal, which gave us this, then you come and work it out like that. Let's see, what is the next question? So they want us to expand 2x squared, expand and simplify the expression 2x squared minus 3y cubed. Let's start with that. Then you write that 2x squared minus 3y cubed. So we have that. Okay. So that is 2x squared minus 3y cubed, and it's squared as well. Then we have times plus 12x squared y cubed plus 12x squared y cubed. So plus 12x squared y cubed. Sorry, that cubed and squared don't look well. So expand and simplify the expression. So this is cubed. And cubed has refused to look well. Now, how do you expand and simplify this expression? Let's try this. So expand, let's start by opening up this bracket. So this would be 2x squared minus 3y cubed times 2x squared minus 3y cubed. So let's start by, of course, with that plus 12x squared y cubed. So let's start by expanding. So we start by multiplying these two by the both of this. So that will be 2 times that is 4x to power 4. So here you apply some laws of indices. X squared times x squared is x power 4. You add the powers. Then again you take 2x times 3. That will be minus, so it's negative 6. Then x and y are not like terms, so they don't have the same basis. So it will be x squared y cubed. Then you come and take 3 times the 2 parts. So it will be minus 3y cubed times 2. So it will be minus. So this is positive and negative. So it will be minus 6x squared y cubed. Then minus times minus will be positive. So plus 9y power 9. So when the base is the same, you just add the powers. So that is, for example, xa times xb. Sorry. Times xb is just equals to x a plus b. So you add the powers. Then you have plus these parts that were there from our original equation, y cubed. So these ones are similar. This and this subtract and it becomes 0. So you remain with 4x to power 4 plus 9y to power 9 plus 12x squared y cubed. Of course, this can be simplified further. And there's a way you can look at this and just try to, you can break up, because this part has okay, let's close that one. So we have expanded and simplified. You don't need to go further than this, because you'll be again going back to the original, to the formats that we had before. So this is the farthest you can get. Unless let's see what the wording of the question. Yeah, that is the farthest you can get. When you expand, your final answer should not have brackets again. Sorry. So we have in the parallelogram, PQRS. Below PQ is 8 and angle SPQ is 30 degrees. Now we want to be able to, they say the area is 24 square centimeters. So this cannot be cubed, it's square centimeters. Find its perimeter. Now let's look at this one. Where's our whiteboard? So it's 8 centimeters. So you have a parallelogram. Sorry for that. Okay, let's use black. Black is gold. So you have a parallelogram. This is 30 degrees. And then this is 8 centimeters. So they are telling you the area is 24 square centimeters. So that's the area. Now here you have a parallelogram that has one side and an angle. So this angle, when you have an angle, the area of a parallelogram is given by this, let's call this one base and call this one H. Or let's call it height. So it will be base times height times that angle, theta. So our base is, so sin theta is sin 30. We remember there is this triangle that we used to do SOHCAHTOA with. So this is 60, this is 60, and this is 30. So this is 1, 1, 2, 2. Then, of course, this one will be root 2 squared, which is 4 minus 1, which is 3. So here it will be root 3. So sine is opposite of SOHCAHTOA. So this one is a common triangle. So sine is opposite of adjacent. So the sine of 30 from that, sine of 30 is given by 1 over 2, which is 0.5. This one you can just find using your calculator. So we will therefore be able to have our area, which is 24, is base, which is 8, times height, times sine 30 degrees. So we go further, this is 24 is equals to 8h times 0.5 or times a half. So let's write it as a fraction because that will make our work easier. So 2 is 1, 2 is 4. So 4h is equals to 24 over 4 over 4. So our length or the height is what? Going to 24 is 6 centimeters. But they want what? They want perimeter. They want the perimeter. So the perimeter P is equals to 2 times base times height. Sorry, plus not times. So it will be 2. Our base is 8. Our height is 6. That's 14 times 2. That is 28 centimeters. So the perimeter is not squared. So the area is squared, the perimeter is not squared. So you have your answer. Let's do. So let me know if you have any questions on that. Let's see if we can do one more, then the rest shall continue that paper later. So we have been given two values, given 9 to the power 2y times 2 to the power x is equals to 72. Find x and y. So 9 to the power 2y, is it properly related? 9 to the power 2y. So we have 9 to the power 2y times 2 to the power x is equals to 72. I think this is too easy. Too easy. Now, 9 in simplest form, let's start with 72 and we try to do prime factorization. So 2 here is, of course, 2 here is 3, remainder 1, 2 here is 18, 2 here is 9, 3 here is 3, 3 here is 1. So this can be written as 72. So 9 is 3 squared to the power 2y times 2 to the power x. Then, of course, 72 can be written as 2 to the power 3, the first 3, times 3 to the power 2. Sorry for that. Times 3 to the power 2. So you see, you equate this, of course, this is 2, this is 2, so they'll be equal. So this means 2 to the power x is equals to 2 to the power 3 and 3 to the power 4y is equals to 3 to the power 2. So our x here will be 3 and our y, 4y will be 2, or y will be 2 over 4, which is 1 over 2. So you have your answer. So that's as simple as that. We shall proceed with this work later, attempts later. So we shall do more other examples. Thank you for following this through. Let me know if you have any questions on the comment side.